Hello everyone, welcome back to my channel, Monica Math Classes. So today we are going to begin with a new topic named trigonometry. And in grade 10 CBSE NCERT, it is called as Introduction to Trigonometry. But before we begin, I would like each one of you to like and subscribe the channel and refer to your friends and relatives too, so that everyone can be benefited. So let's get started. And also don't forget to enjoy your learning. So trigonometry, that's the branch of mathematics. That is something new with each one of you. So it looks like this. So what is trigonometry? The first question is, what is trigonometry? So trigonometry is a branch of mathematics, as I told you, and it focuses on the relationship between the sides and angles of a triangle. And most important, it is a right angle triangle. Okay. So the word trigonometry came from the Latin derivative of Greek words for triangle, which is trigonon, and measure, which is metron. So trigonometry, if you combine together, it is the measurement of the triangle. So how does it help you? So it's a very important question. Said, why are you learning this new branch of mathematics? Because it will help you to find the unknown angles or the missing sides of a right angle triangle. Basically, you're going to work you're going to work in a right angle triangle, which will help you to calculate trigonometric formulas, functions, or trigonometric identities. So what are its uses? Why are we doing it? So in real life examples, to geography, to astronomy, you actually use it in many places other than what you are going to do in this topic to calculate the angles and distances. So it is used in astronomy too, in map making, in surveying, in artillery range. So you use a lot, and in other branches of science as well, in electronics and electrical engineering, civil engineering. So when you learn physics, you will see that if you know trigonometry in your grade 10, 11, and 12, you're going to use it a lot. So it's very important that you know this. So who is the father of this trigonometry? Hipparchus. So in 2nd century BC, there's a Greek mathematician, Hipparchus, who made the discovery of trigonometry. Actually, he's a mathematician and he's a geographer too. So in addition to solving various spherical trigonometric issues, he produced the first trigonometric table. So that's very important that we are going to learn in another few minutes. Okay, so this is the man who discovered trigonometry. So a very important part in this, what are trigonometric ratios? The whole trigonometry is based on few trigonometric ratios that you are going to learn with me now. So what are these ratios? The ratios involves the sides of a right angle triangle. Okay, so let me begin with saying this sine A. So before I start with sine A, this is not a product of sine and A. It is a single symbol, okay, sine A. You cannot separate it. So A, it could be an angle. So suppose it is a right angle triangle, and let me name this as A, this as B. So this is a right angle triangle, which is right angle at B. And from grade 7, you start with a right angle triangle. So you should know what are these sides called. So this is called as hypotenuse, which is the longest side in a right angle triangle. This is called as base, and this is called as perpendicular. Few people called it as height also, doesn't matter, but I will call it as perpendicular because in CBSE we always called it as perpendicular. Now, how you're going to define this? Sometimes they call it as this as angle as theta, that is also fine, doesn't matter. So you calculate as sine theta or cos theta, still the same. So I'm calculating sine A. Now what is sine A? Sine A is always perpendicular upon hypotenuse, perpendicular upon hypotenuse. So you will always remember. Okay, so perpendicular upon hypotenuse, you can say as P upon H as well. And sometimes people remember perpendicular as BC, they write it as the side's name, BC, and hypotenuse as AC, BC upon AC, that is also fine. But always you have to remember as P upon H, perpendicular upon hypotenuse. This will help you. Your AC, BC, everything will change according to the question. Sometimes they say that the right angle at A, right angle at C, then what will happen? It will change. Your perpendicular and hypotenuse will remain the same. How do you look at it? Okay. So suppose this is your sine A perpendicular upon hypotenuse. So this is the ratio of these two sides. Now cos A. Cos A is base upon hypotenuse. So remember, it is always base upon hypotenuse. Now in this case, my base, I always remember as B upon H. Okay. And my base is AB and my hypotenuse is AC. It's still the same, yeah? So for perpendicular and base, if you see, you're calculating for A, for this angle. So your base is this and hypotenuse is this, but hypotenuse remains the same. Tan A. Now tan A is perpendicular upon base. Perpendicular upon base. Now how do you write it? Do you write it as P upon B? And your perpendicular is BC and your base is AB. Something very interesting I want to tell you here itself, that tan A is actually can be written as sin A upon cos A. Now, if you know this as well, so you don't remember it is perpendicular upon base. So you divide this P upon H divided by P upon H, you divide this by B upon H. What will happen? This H will cancel out. What you're left with? You're left with P upon B. So still the same thing, perpendicular upon base. So a very important part is this, that trigonometric ratios are the ratios of these sides and you have to remember it by heart. So there is no shortcut, there is no trick to it, but let me tell you one more thing. So you have calculated just for this, okay? And right now this is right angle at B and this is at C and okay, this is as A. Now sometimes what happened, your hypotenuse will remain the same, okay? So there is no change in this. But what happened? You have to calculate for C, for this angle. Now, when you calculate for C, suppose they ask you sine C, how do you calculate that? Which one is your base? Which one is your perpendicular? Hypotenuse still the same, okay? So there's interchange for perpendicular and base. Now you calculating for this. Now opposite to this angle, so opposite to this angle, you have this. We will take this as perpendicular and we will take this as base. So you have to remember this part. If you are calculating for C, so you have to look at what is opposite, which side is opposite to this angle C. That becomes your perpendicular. Now look at this A. Which side is perpendicular to this A, which is this BC? I made it this as perpendicular. So the thumb rule is, if you have to calculate this particular angle, you have to find out which side is opposite to this. Okay, that side becomes perpendicular. Now, if I have to calculate sine C, I know it is perpendicular upon hypotenuse. So this will become AB upon AC. So it changes. So you have to remember this. This is a very important part. I hope you're clear with this. Now, there are actually 6 trigonometric ratios. So 3 you got to know. The other 3 are the reciprocal of this. Now, reciprocal of these above trigonometric ratios. So T ratios means trigonometric ratios. So when I say cosec A is the reciprocal of sine A. So remember this. You don't have to remember every time perpendicular upon hypotenuse, it becomes hypotenuse upon perpendicular. Just remember few key things and it becomes very easy for you. So cosec A is 1 upon sine A, sec A is 1 upon cos A, and cot A is 1 upon tan A. Now, do you remember still? Now, in case you don't remember, I'll take you to this. Sine A is perpendicular upon hypotenuse, and reciprocal means upside down. It becomes hypotenuse upon perpendicular. So this one is hypotenuse upon perpendicular. So only you have to remember this. Again, I'll take you back because you don't remember still. So sec A is the reciprocal of cos A. What is cos A? Base upon hypotenuse. So that becomes hypotenuse upon base. It becomes easy, you know. It's not, we are human, so we have certain capacity. We cannot remember everything, but with logic, we'll remember everything. So now here, cot A, which is reciprocal of tan A. Now tan A is what? Perpendicular upon base. So it becomes base upon perpendicular. So see, it becomes so easy for us to remember. So in trigonometry, there are few key things which you have to remember. The first is your trigonometric ratios. Now, trigonometric ratios, the first 3 you have to remember by heart. Probably you don't remember for 3, you can remember for 2, sine A and cos A. or I would say sine theta, cos theta, doesn't matter. I told you that where your angle should be, accordingly you have to see. But you have to remember key things, which is perpendicular upon hypotenuse and cos is base upon hypotenuse. And for this is tan A, it is sine upon cos. So in case you forgot, you can see sine and cos. So it is perpendicular upon base. Things are really easy. It's not difficult, but you should know the tips and tricks to remember it in mathematics. Because sometimes it's not about calculations, it's about logic. And trigonometry is a logical thing, as well as calculations later on. So there are important points to note, as I told you, that sine A is a single symbol. You cannot, see it separately, sine different and A different. They are together, sine A, sine of A, sine of that angle. Now, next is in a right angle triangle, the hypotenuse is the longest side that we know it. Therefore, the value of sine A and cos A is always less than 1 or at most equal to 1. Okay, so remember this. See, this is Hipparchus who made this table, and this we have to remember it. And I'll tell you the tips and tricks as I told you, because this is the main motive to know everything with ease. So trigonometric ratios of some specific angles, for all of them will remember, I'll tell you how to make it. Because as soon as you get any question to calculate some angles, you have to remember it. So it starts from 0 till 90, 0 to 90. And what are the angles in between? 30, 45, 60. I will remember only one. So in my childhood, I only remember one and I know how to make the other angles. So let's do it. Sine 0, 0, sine 30, 1 by 2, sine 40, 1 by root 2. They have given you this, but you know rationalization, it becomes 1 upon root 2. 60 root 3 by 2 and 90 is 1. And the other angle, it looks really difficult in the beginning, as you said, but we are going to make it right now. So remember, you have to remember this, and you can come back again and again and see the video, how to make it. We are going to learn how to remember the table, how to form a table. So there are tips and tricks to remember it. You don't need to remember it, each and everything of it. So in the beginning, you all have to remember only sine A. So one trigonometric ratio, you remember, the other will be on its own. Automatically it will come. So you have to remember it. The first one, I have remembered it. So you also please remember it. Sine 0 is 0. Sine 30, 1 upon 2. Sine 45, 1 upon root 2. Sine 60, root 3 by 2. And sine 90 as 1. Okay. Now, how to go for cos A? It will go in the reverse order. It will start from the 90 from here like this. Now, for cos 0, it becomes 1, okay? And for cos 30, it becomes root 3 by 2. So I'm writing in the reverse order from the back. Cos 45, the same as 1 upon root 2. And then cos 60 becomes 1 by 2. And cos this 190 has become 0. So have you seen? I'm remembering only one sine, and from sine only I'm making cos. It's very easy. Now, what is the relationship of sine and cos? It has a relationship. Sine upon cos makes tan. So we are going to take benefit of this. Okay. So 0 upon 1 becomes 0. So you look at the column of 0 degree. Okay. Now you look at the column of 30 degree. So tan, I'm dividing sine upon cos. So 2 and 2, 1 by 2 divided by root 3 by 2, 2 and 2 cancel. So you got 1 upon root 3. Then you have 1 upon root 2 and 1 upon root 2. It will cancel completely. So you get 1. And this one in tan 60 degree. So you have this 2 and 2, which will cancel. You will get only root 3 and 1 upon 0. Anything divided by 0 will give you undefined or infinity. Now, to write for cot, you have to write in the reverse order. Means whatever is now 90 for tan becomes 0. Okay, cot 0. So here I will start from infinity. Then the next one becomes root 3, then 1, then 1 upon root 3, and then it becomes 0. I think so far you have understood that how I'm writing in reverse order like this. Now, what is the relationship of sec with cos? Sec is the reciprocal of cos. So if I know this, it will help me to write the values for these angles. So sec 0. So here I have to look only for cos. Okay. So 1 upon 1, it is 1 only. And root 3 upon 2, it is reciprocal, so it becomes 2 upon root 3. Then we have 1 upon root 2, which becomes root 2. This becomes 2, and this becomes what? 1 upon 0, it becomes undefined infinity. Okay. Now, again for cosec, you have to write in reverse order. Now, whatever you have write for 90, sec 90, it becomes cosec 0. So this becomes infinity, this becomes 2, this becomes root 2, and 2 upon root 3, and this becomes 1. So I hope you have seen that how easy it is to make this trigonometric table, right? So you don't need to remember all the angles for all the trigonometric ratios. You only remember one for sine, and then make the other trigonometric ratios with the help of this. Next is trigonometric identities, because your questions are on these. So what are identities, which is true for all values of variable? Means you put the values of it and you get the answer. Just like the algebraic identities, remember, we have trigonometric identities. Now, what if I tell you you only have to remember one? Because I also remember one, and from that I make up the other two. So you have to remember sine square A plus cos square A is equal to 1. Easy, no? This is very easy. Both a square and it is equal to 1. That's one trigonometric identity. There's a proof also. Okay. So all these things which we are writing, it doesn't come just as it is. There is a proper, proof. How did we arrive at this? Now, next thing is, how do we get the another one? Okay, I'll tell you the key. So for the second one, first you divide the whole equation by sine square A. Now what happened when you divide the whole equation by sine square A? So you got sine square A upon sine square A. You have to divide it. So divide plus cos square A upon sine square A. And here also you have to divide on the right side upon sine square A. Now what happened? Sine square A upon sine square A, it becomes 1. Cos square A upon sine square A, it becomes cot. Remember I told you? Okay. So cot is the reciprocal of tan. Tan is sine upon cos. So it becomes cot. And this becomes 1 upon sine is, it is cosec square A. So you got this third one. Okay. So that's how you will prove it and remember it if you don't know. And the next one, divide by, this time I'm going to divide for, so this is your first case, and for the second case, you're going to divide by cos square A. Now, when you divide by cos square A, what happened in this? So this is my equation, I'm dividing in this, okay? So let me write this first equation, sine square A plus cos square A is equal to 1. Divide this by cos. What happened? Something will happen. Something will change and you get another one. So, so sine upon cos is tan. I told you, yeah. So tan square A plus cos square A and cos square A cancelled out. You got 1, and 1 upon cos is sec. See, you got this second one. 1 plus tan square A is equal to sec square A. I hope you're finding everything is easy, because along with it, I'm telling you the tips and tricks. And this is, I told you that tan is made up of sine upon cos. So there are many places in questions, in solving, we need these things, okay? So as I told you, the things which you need to remember that, and which you can't, there are tips and tricks for it. So don't worry. So we will do one question on it, and in the next video, we will do more questions on this exercise 8.1, where you have to solve a lot, okay? So let's begin with the first question, okay? So there is a triangle ABC, okay? We will make a right, as I told you, it's always deal with only right angle triangle. Now, the important point is, it is right angle at B, so we will make right angle at B, okay? You make A and C here. So as per this, write down what are the sides given. AB is 24 centimeter and BC is 7 centimeter. Okay, and you have to calculate sine A, cos A, sine C, cos C. And how do we get that? We can easily get this once we know what is hypotenuse also. How to get this hypotenuse part? We have to use Pythagoras theorem. So using Pythagoras theorem, let's begin. So using Pythagoras theorem, you have to, I hope you remember hypotenuse square is equal to base square plus perpendicular square. You know why because I have to calculate for first of all for C. Okay, so this is C, and for me, the opposite is this side, which is perpendicular, because I will calculate for this. This is my base. Okay, so hypotenuse base is 7 square and perpendicular is 24 square. 7 square is how much? 49, and 24 square is how much? 576. I hope you remember, still remember your grade 8, all the squares. This will help you to calculate fast. In exam, you need such squares and cubes. And that is the purpose they have given you till at least from 1 to 20, they have given you remember till 1 to 10 or 1 to 15. Okay. So, but when you do a lot of calculation, you will automatically remember a lot. So 49 plus 576, it becomes 625. So hypotenuse square is 625. Now after this, what is the square root of 625, which is 25 centimeter? So here it is 25 centimeter. Now I'm calculating the second part first because here I'm calculating for C, which is perpendicular opposite to it. Then I will calculate for the first part. It's easy because it is made in such a way. So here, first sine C. So according to this, perpendicular upon hypotenuse, do you remember? So what is your perpendicular? 24. And this is 25. And what is cos C? Cos C is equal to base upon hypotenuse. Okay, remember. So which is 7 upon 25. So this is my ratio. This is my answer for second part. But I have to tell you for sine A and cos A. So I have to make it again. So make a right angle triangle. Okay. And which is, let me see, it is right angle, let B, and B is here, A is here, and C is here. Now I have to calculate for A. Okay. Now, as I told you, I have to calculate for A opposite to this. You have to look. So this becomes your perpendicular, and this becomes your base, and hypotenuse never changes. So remember all this. These are very important things. Now you have to write down everything. So here AB is 24. Okay, so this one is given as 24 centimeter, this one is 25 centimeter, and this one is 7 centimeter. Now you have to calculate for sine A. So sine A is perpendicular upon hypotenuse. Now you tell me what is perpendicular? It is 7 upon 25. And for cos A, it is base upon hypotenuse, which is 24 upon 25. And that's my answer. So remember, so now here, if you look back, you'll see that sin C and cos C has a different answer, and sin A and cos A has a different answer, depending upon what angle you want to calculate. So you have to keep in mind all these things. So let's do a quick recap before we sign off. So today we have learned about trigonometry. And in trigonometry, we have understood what actually the trigonometry is. It is a measurement of the triangle, and basically we deal with the right angle triangle. And how does it help you? There are many real life examples other than you calculate unknown angles and sides of a right angle triangle in astronomy, in geography, in map making. You use a lot. In physics, you use a lot. If you don't know trigonometry, it's very difficult to calculate the numericals in it. Next, who is the father of trigonometry? It's Hipparchus, who is a Greek mathematician. He's actually a geographer too. So because he has to calculate some sides and angles, the distances, that's why he came up. So he got first trigonometric table. Okay. That I helped you, but we will revise it again. So what are trigonometric ratios? That's the very important first key thing to remember. So there are first 3 trigonometric ratios you have to remember. It is based on right angle triangle. You should know what is perpendicular, hypotenuse is base. So sine A, suppose sine theta, whatever you like to call, it is perpendicular upon hypotenuse. Cos theta is base upon hypotenuse. Tan theta is perpendicular upon base. And then the reciprocals of these trigonometric ratios, and together there are 6 trigonometric ratios. You have cosec A, which is 1 upon sine A, sec A, which is 1 upon cos A, and cot A, which is 1 upon tan A. Then next is your trigonometric identities. So you have to remember 1. Sine square A plus cos square is equal to 1. The other 2 will be based on the first one. Then you divide first by sine square A and the other by cos square A. It is very, very easy. The things are really not difficult. When I say it's easy, it is. Next, Then there are questions based on this. So we have done with very simple and easy one. That's your first one, so that you understand whatever angles they want you to calculate, you can easily calculate it. So I hope you've understood today's class. So I hope you've enjoyed today's class. And in case you have any doubt, you can go back again to this video and practice it, because as I say, practice makes the man perfect and permanent. So by then, I want each one of you happy learning and keep practicing. Rise and shine, Monica.